Well, the following 6 problems all refer to the original 4 problems that we had to begin with. So if we're simplifying each expression, we're doing more of the same. We're taking the f function, which is 2 times something squared, but we're putting in a different function this time. Okay, we're putting in a 2x minus 4, because that's what this is. And you end up foiling the same way. Again, it says to simplify factored form if possible, so you're going to FOIL that and distribute the 2. In this case here, it's the k equation you're referring to, which is equal to 2 times something minus 4. And this time, though, you're putting in the 1/2, putting in this other equation. So each time, look at the outer variable, go to that equation, and remove x, and in its place, put a set of parentheses. Then you can kind of revisit and say, okay, well, what goes in the parentheses? Oh, yeah, it's this. So there's your 1/2 x. I didn't leave much room, plus 2. But again, the distributing and all that, I guess I can go through this one with you. Half of 2 is 1, so that's a 1x. You're distributing the 2 plus 4, because 2 times 2 is 4, and then minus 4. Well, that's weird. These cancel. You end up with just x. Whoa, that's cool. Talk about that later. This is a FOIL problem, f of x and g of x. Well, it wouldn't be a FOIL problem in this case because it would be 2x squared times g of x, which is x minus 2. So you'd have to distribute. I'll let you do that. H of x and k of x. Now this is a FOIL. That's where you're going to take the 1/2 x, which don't get too worried about that. That's something you can handle. And then 2x minus 4, which is the, oh, that's a minus. I got an eraser here. We're about off the page. Minus 4, which is the k of x equation. This one, and again, foiling would be the appropriate thing to do at this point. First outer inner last. 4 terms that will become 3 terms. K of x over f of x. This one here, there are traditionally difficult things. K of x is the 2x minus 4. F of x is the 2x squared. Now, some of us like to just say, oh, I'll just cancel the way I want to because it seems easier. Cancel these 2x's and stuff like that. Well, you can't. Okay? You can only reduce something if something on, for example, let's say this 2. I know it looks like it just goes into that 2, but it needs to go into both. Conveniently enough, it does. So the best way to approach would be to say, is there something I can factor out of here? If there's nothing, then it can't be reduced. But if you can factor something out, that's the thing that has the potential to be reduced. You factor out a 2, you're left with an x minus 2 all over 2x squared. Now you cancel the 2's. Now you're left with an x minus 2 and then an x squared on the bottom. And over here it's a combined like term fest. So it's that equation plus that equation minus that. The only thing I can throw in that you might want to consider here is when you subtract the k of x, I would use parentheses to remind yourself that that is a 2x minus 4. And then what I would do after blah, 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 all this, I'd change that to a plus, change that to a minus, change that to a plus. Then you can just combine your like terms from that point. But that's all I'm going to give you. Enjoy.